During the last class, we established the idea that DNA damage is a fact of life. It happens at all times due to the chemical nature of DNA. We also established the existence of four main ways of dealing with DNA damage and covered the first two mechanisms: direct reversal and excision repair. In this video, we'll briefly cover translation DNA synthesis. For starters, it is important to establish that translation DNA synthesis is not really a mechanism to repair DNA damage. Instead, it is a way to ignore it, allowing DNA replication to take place so that later on, real ways of fixing DNA damage may take care of fixing such damage. It is also important to note that the translation DNA polymerases are error-prone and therefore are likely to introduce errors in the process, but they are able to put the right nucleotides in the strand complementary to the damaged strand. Any errors introduced by the translation DNA polymerase, as well as the initial damage that triggered translation DNA synthesis in the first place, are later on fixed by excision repair. Translation DNA synthesis takes place when DNA damage, usually of the type exemplified by thymine dimers, halts DNA replication. Under those conditions, the DNA polymerase falls off the DNA template and is substituted by a specialized type of DNA polymerase that is endowed with the ability to continue DNA synthesis over the damaged DNA, being able then to put the right nucleotides on the complementary strand and therefore allowing DNA replication to continue. Once the DNA has been replicated by translation DNA polymerase, that polymerase falls off due to its low processivity and is replaced by a highly processive DNA polymerase that then continues replicating the DNA. DNA damage is later on corrected by excision repair, specifically by nucleotide excision repair, therefore producing in the end a replicated DNA without any errors in its sequence.